Hello everyone, my name is Mehmet Selim. I am a PhD student at Physics Department in Çukurova University. I'm going to talk about structural, magnetic and magnetocaloric properties of lanthanum sodium manganate. Today I will briefly encode with L and M. My presentation have four main sections. As a result of increasing expectation regarding climate change, population growth, and living comfort, energy demands for cooling technologies are increasing worldwide. In addition to the increasing energy demands, it becomes necessary to develop new technologies that can replace the cooling system that are widely used today in terms of harming the environment and health. This figure shows energy usage in the residential sector. As can be clearly seen in the figure, the most energy consumption is required for heating and cooling system. The magnetocaloric effect was first observed in 1991 by the German scientist Emil Warburg on a piece of iron. And the magnetocaloric refers to the change in the temperature of a magnetic material when a magnetic field is applied. This figure shows working principle of magnetic cooling system. There is a magnetic material and magnetic field which is applied or removed. Once the magnetic field applied on the material, temperature of material will increase and it will decrease after the removing magnetic field. This figure shows schematic representation of the working principle of magnetic cooling and compressing cooling system. Magnetic cooling is an alternative cooling technology that can operate without gas-based coolers. Compared to the gas compressed system, they have advantages such as not containing environmentally harmful cooling materials, being more efficient, compact system, and operating without noise and vibration. Although it has been heard by everyone for a long time, magnetic cooling technologies cannot yet be used as a potential cooling method in our daily life and industrial areas. In the production of magnetic material with high magnetic caloric effect, doping elements and their quantities, as well as the material production method, are of great importance. In this study, Sol-Gel method was preferred due to its advantage such as obtaining thinner and homogeneous dispersed particle size. First, the appropriate stoichiometric amounts of the starting compounds were determined. Incineration was applied for 1 hour in the muffle furnace at an average temperature of 550 centigrade degree. The powder sample to be uh, obtained was subject to calcination of 600 centigrade degree for 6 hours in order to remove the compounds residues to be added to the structure as a gellant agents. Then the samples were ground in agate mortar with 4 grinding sessions of 10 minutes each for a total of 30 minutes. As a final process, it was sintered in the cylindrical furnace at 1000 centigrade degree for 24 hours to crystallize the materials. For understanding structural features of the produced sample, the X-ray diffraction method was used. The crystal structure of the sample were determined by using the obtained XRD diffraction patterns and the lattice parameters have been calculated. Scanning electron microscope technique has been selected to obtain a grain structure image to analyze morphological features. All analyses have been studied at Çukurova University Central Research Laboratory. Uh, this figure quantum design physical property measurement system. We use PPMS device for magnetic measurement and calculate the Curie temperature and delta SM value. This figure shows XRD pattern of LNM, and this table shows lattice parameters and unit cell volume of LNM compounds. According to XRD result, uh, LNM have hexagonal phase, and sharp and narrow base diffraction peaks are seen in the diffraction pattern of the compound, which indicates that the crystallization of the compound has taken place well. In addition, it is understood that the XRD pattern of the compound does not have peaks belonging to the impurity phase and almost monophase. And we have four different magnification of same image in this figure. Uh, there are different size of particle structure, and their shapes are polygonal. The transition temperature values, Curie temperature of the materials have been determined from the MT curve, and the magnetocaloric features have been examined from the isothermal magnetization curves taken around this determinate temperature. The peak at the transition temperature is given in the derivative MT. The sample detailed transition from magnetic to paramagnetic at Curie temperature. In order to determine the magnetic entropy change, field-dependent magnetization measurements were carried out for each material in its transition temperature region up to 5 Tesla field value at 4 Kelvin temperatures steps. This figure MH graph, if you look at the magnetization curves, they dramatically increase at low temperature region and linearly increase at higher temperature, and this is the result of the fast transition ferromagnetism to paramagnetism. You can see magnetic entropy change graph at the left hand side, and the details are given in the table. When we compare with the literature, it is clearly seen that we obtain a Curie temperature value near room temperature and high delta SM value. Curves can have a positive or negative slope. If the slope of curves is negative, it means that there is a first order magnetic fast transition, and it is needed to vanish and the thermal antihysteresis for this type of materials. On the other hand, if the slope is positive, then there is a second order magnetic fast transition. Based on the above two rules, it is understood that the LNM has a second order magnetic fast transition from the arrowed plot. According to XRD result, it has been determined that it is hexagonal structure. The transition temperature 311 Kelvin, delta SM value 5.64, and under a magnetic field change of 5 Tesla. According to the result, LNM magnet can be a candidate, one of the potential magnetic refrigerant materials for near room temperature application. We are grateful that this work is supported by Çukurova University scientific research projects. This is my reference. Thank you for your attention.